Lab 15 hierarchical block. Now in this lab we're gonna study the hierarchical block that look like similar to one. So this will formation of the just a block. Inside we can have like a divider circuit. First start a new project with a divider, place select chapter 15. Create a blank project. This will open a go in the place toolbar, open a page hierarchical block. In the reference write HB1 no primitive. In the implementation schematic view, implementation name vdivide, and leave the path blank. Click OK. Now just drag the fields where you want to make a block. This will form a HV1 with vdivide as implementation name. Now make the port or pin. You can go again in the place hierarchical pin. In the pin name the pin as input in scalar input. These are the input for the block. Form an output. In the complex circuit, the formation will be done by the blocks because it becomes very complex for a whole circuit to be represented by each component. So we use the block hierarchy. Select the same we did for input. So go for the output pin. Apply. The R is for the output. Use the VDC as a source for the input. The groundings. $10 DC. 10 volt DC like an input to the block, and the load resistance of 100 G as an output connected to ground, and in between there is a block of V divide. Name the simulation. Hierarchical block. That's how we form the input and output pin. Do as I am doing in the video. So this is means that we have input and we have output, same over there, H1 block, and in between we connect a resistor. This will lead to formation of a bias point analysis. Ascend hierarchy. So this one is the block we did it, and we're gonna now form a that's the net list. This shows that our block is connected, the points are connected, the node voltage node with the so voltage at the node output is the half of the voltage at input. Input we have 10 volt. Now make a new project. In this in the previous lab we used the top to down design approach. We make ascent, then we make a descent. Now in this lab we will turn a clipper circuit into a block. So we have already formed a circuit, a clipper, and we want to make it in a block. So we are forming a new hierarchical clip project. Now in the blank schematic, blank project page, now copy paste that previously designed the clipper circuit. So we're gonna have all these things. We wanna make that win in the block. Go on a new rename as a clipper. Clip underscore add a library In the library, use the save as. In the new property, name this as a clip underscore top. So in the library we are adding as a top, schematic is named as a bottom. So library is top. In the implementation schematic view, and what we're gonna implement is the clip bottom. So clip underscore bottom in the implementation. Make a rectangle shape. Now click the place pin. Click place pin. In the place pin, input name as an input, shape as a short, number as a 1, shape as a short, number as a 1, and type as an input, width scalar. So this will make a pin, input pin for our block. Now click on the left hand side of the pin to place the pin. Now we have to form the two other pins, the output and the mid, same way. Now go in the place, click on the place pin, mid, name as the mid, short, input, number 3, I'm sorry, width scalar. This will form the mid as an output pin. And the second pin will be the third pin will be the mid, and second pin is the out. Place pin, and the go output. Name the block as a go in the project manager back, add a new schematic called clip top. So this one is the clip top, the block, and in the clip top like a root command, Like a page 1. So in the clip top there is a page 1. Now in the design property, go in the journal. Now scroll down, select the library, clip top, add the library, edit the properties of the library. In the primitive, go no. This is the important step. Connect the source voltage AC VAC in the source library at 1 volt AC. In the output 210G of resistance. In the analog library you find resistance 210G resistance. Place the ground, 2 grounds. Connect the all circuits. Take R1 as a 10G, R2 as a 10G. Make a new simulation lab 15. PSpice A2D we need. VD simulation of AC sweep. AC sweep at the logarithmic scale. Start frequency 10 and 100 megam points per decade 11. Press OK. So this is the output, 110 hertz to 100 megahertz, and in the frequency select V input, V1, U1 is the block name which is coming over here. So this is frequency and V out of U1. U1 means the block. So this is the green is the input, red is the mid one, now over here we will see the difference between the flat netlist and hierarchical netlist. Search for the part, click, click on the subparam. So subparameter select as an R val. So in the subparameter make a default value of 1. The subparameter has the value of name will be like rval and the value will be 1. And in the display select the name and value. Select the value at RVL. So we have using the two blocks. So one have a we connect the output. This both are connected to the same output. So both have same load resistance and this both have the same input. So two block are there present. Now one block, the U2, Just make it properly visible. The two blocks are there. The first one is U3. Edit the property of it. Add a new row. Name a parameter as a rval. Because we are using subparameter rval for all analysis, we have to make rval added to every block and make the initial value of that one as 100k. So for U3 we have 100k of rval. Apply to the circuit. In the uval, apply, add a new row rval. They have a value of 20k. Apply this new column row to the R block U1. So U1 have an R value of 20k. So this is the two block with two different rval. So there will be the netlist creation. Now this will create a traditional flat netlist. Click on the view netlist. So this is the netlist. Notice that there are two entries for every device. For every device you will find two entries. So 20k and 1k. Go to the project management and choose the tool and create a nest list. Now this will create a single netlist for the whole hierarchy. Click the PSpice tab. The PSpice create hierarchical format netlist. So this will create a netlist for the R blocks. Click OK to generate the netlist. So this is what we need for the hierarchical. So check our browse point. This is for the subcircuit defined generated, like they are not as before. It's generated only for subcircuit. The source and the subcircuit